We're ready to take a look at multiple horizontal transformations. And with the first problem, I raise what I think is an interesting issue. We have two students, Harold and Maud, who are having an argument about how to correctly do a math problem. They've been asked to sketch f of x, which is the square root of 2x minus 4. And they both agree, and they're both correct, that that's equivalent to the square root of 2 times x minus 2. Because if I distributed this 2, it would just become 2x minus 4. So they agree these are both valid formulas for the same function. Now I graphed Harold's answer here and Maud's here, and let me just explain their reasoning. Maud looked at this and he said, oh, we're multiplying by 2. I know that's going to be a horizontal shrink. And we're subtracting 4. That's going to be a shift. So what he did is he did a shrink and then translated 4 units to the right. And basically each of them was keeping track of 3 important points. On the parent function we would have the point 0, 0. And so if you cut this in half, it's still 0. And if you add 4 to it, it's going to put you at 4. So that's how Harold got this starting point. Here, for the point whose y value is 1, if you cut this in half, you would get 1/2. And then add 4 to it, you'd get 4.5. Okay? So that's the way Harold approached the problem. Maud looked at this version and said, that's multiplying by 2. That's going to shrink things by 1/2. Subtracting 2 is going to shift things to the right 2. So she did a horizontal shrink and then shifted to the right 2. And she got this graph. Notice with this x value, if you shrink it by 1/2, it's still 0. If you add 2, that's going to put us at 2, 0. If you shrink this by 1/2, it's 1/2. If you add 2, that's going to take us to 2.5. So they got 2 different graphs, and only one of them is correct. And I want to point out something that I think is kind of interesting. Here, Harold respected the order of operations. We would multiply first and then subtract. So he did the transformations in that same order. He did the shrinking, which would correspond to the multiplication by 2, and then the shifting. When we write it this way, we do parentheses first. So Maud went against the order of operations. Evaluating these, I would subtract 2 first because it's in parentheses, and then multiply by 2. But Maud did the shrinking first, even though the multiplication by 2 would be done second. So the difference is not which version of the formula they used, because you can actually do this problem correctly using either version of the formula. The difference is one of them respected order of operations, one of them did the opposite of the order of operations. Who's right? Okay. So what I want you to do is pause the video and see if you can figure that out. Think about it for a little bit. Make a guess. I honestly don't care whether you make the right guess or the wrong guess. I want you to think about it. I want you to let your brain struggle and engage with it and make a guess. If you're right, fantastic. If you're wrong, fantastic. But you're going to learn more if you actually make a guess and think about it. And that way you can say, I was right, hooray. Or, oh, I was wrong, and here's why I was wrong. And it's going to stick with you a little bit more. So pause the video right now. See if you can figure out. You can figure it out by thinking of order of operations, or there's actually a much simpler way, I think, of figuring out which one is right. Pause the video, see if you can figure it out, then tune back in. I think the simplest way to figure out who's right is to just pick these points and see if they're actually going to make the equation true. So Harold has a point 40 on here. If I plug that in for x, 2 times 4 would be 8, minus 4 would be 4. The square root of 4 is not 0. This point is not on the graph. So Harold is wrong. Okay, I know he's wrong because that point can't possibly be on the graph. As soon as I get one point that's wrong, I know the answer can't be correct in its entirety. Notice if I plugged into this version, I'd get the same thing. If I plug in 4, 4 minus 2 is 2, times 2 is 4, square root of 4 still isn't 0. So it doesn't matter which version of the equation I use, this point is not on the graph. Let's try Maud's point. If I plug in 2, 2 times 2 is 4, minus 4 is 0, square root of 4 is 0. Or if I used this version, 2 minus 2 is 0, times 2 is still 0, square root of 0 is 0. I can check all 3 of these points. They are all 3 on the graph. Now, that doesn't prove that Maud's graph is correct. That just proves that those 3 points are on the graph. But I told you one of them was right. Once we know it's not Harold, it's got to be Maud. Now, I also mentioned before we paused the video that Maud went against the order of operations. She did them in the opposite order. If you remember, when we looked at just single horizontal transformations, they were a little bit counterintuitive. Adding a number shifted things to the left. Multiplying by 2 made things smaller horizontally. So that theme that horizontal transformations are a little bit counterintuitive, so that they don't respect order of operations, seems to be still continuing. I want to just take a look at why we need to go against the order of operations here. If I were to create a table of values, I'm going to use this version, but then we'll do it again doing this version and see that we get the same graph. So it doesn't matter which version you use. I kind of prefer this one. Both Harold and Maud did the shrinking first and then the shifting, and I think that's a little bit nicer. So I'm going to try to set things up so that we do the stretching or shrinking first and then the shifting, which is what we would do in this case. So the thing I'm plugging into the square root is 2 times x minus 2. And then I'm supposed to calculate the square root of 2 times x minus 2. Now, if I were trying to solve for x, what I might do is if I started with x, just doing the order of operations, x, I would then get x minus 2, then I'd double it, then I'd take the square root. This table shows me the exact order in which I would evaluate things. But if I'm starting with this and setting this equal to my nice values, that it's easy to take the square root of, so that I get these nice y values of just 0, 1, and 2, notice in solving for x, I'm working backwards. So if I say that 2 times x minus 2 is equal to 0, which is what we're saying right here, the first thing I would do in solving for x is I would divide by 2, which would give me that x minus 2 is equal to 0. Oops, sorry, that's x minus 2. Then I would add the 2 over, and so I would get x equals 2. But in doing that, I was working backwards. If you're solving for x, you're undoing things, and you're doing that in the opposite order of the way you would evaluate things if you were plugging in a number for x. So when we do the corresponding transformations, we're going to do them in the same order that we're using here in solving for x, which is essentially the opposite of the order of operations. With the other points, if I had 2 times x minus 2 equals 1, first thing I would do is divide both sides by 2. X minus 2 would be 1/2. Then I would add over the 2 to get x equals 2.5 or 2.5, however you wanted to write that. Okay. So it's because in figuring out what x is, we're undoing the stuff that we're doing to x, and we undo things in the opposite order in which we do them, that we do not respect the order of operations. We actually go against it. Okay. I think a simple way of remembering that is if I go with this table that I create, where I would say, let's evaluate our function, and then let's write down the corresponding transformations. Okay. That basically is encoding the information that I have in the column headings for this table. I would start with x. I would first subtract 2, then I would multiply by 2, and then I would take the square root. That's the parent function. So this stuff that I'm doing here, we're doing before the parent function. So that's what tells me that it's going to give me horizontal transformations. And then I know that this is going to be shifting things to the right 2, and this is going to shrink things by a factor of 1/2. And that was the order in which Maud did those things, and that worked. That gave us the correct graph. Essentially, if the parent function is here, I know vertical transformations correspond to things I do after evaluating the parent functions. And vertical transformations, I follow the order of operations. Horizontal, I go against them. But basically, the rule is you're always working away from the parent function. So if the parent function is here, first thing I would do is shrink, then I would shift. And then for vertical transformations, I would just go straight down, following the order of operations. Now, I mentioned that I like using this version of the formula better than using this version of the formula, but that either one of them is actually correct. Let's just show how we can get the correct graph using this version. If I used this, if I'm evaluating things, and then I can write the corresponding transformations, okay, the first thing I would do to x is multiply by 2, then I would subtract 4, and then I would take the square root. Now the square root, that's my parent function. So everything I'm doing before then is a horizontal transformation. Okay. Multiplying by 2, I know that's shrinking things by a factor of 1/2. Subtracting 4 is shifting things 4 to the right. But I have to do them in this order, working away from the parent function. So if I just work with these points that I have in my parent function, let me just sketch that real quick. Here's 0, 0, 1, 1, 4, 2. So if I shift everything 4 units to the right, I'm going to have this point 4, 0, and then I'm going to have a point 5, 1, and then I'm going to have a point 8, 2. So this point 4, 0, which I know is not on the final graph, is actually on the graph of what I get if I just shift 4 to the right. But now I've got to do the shrink. And when I shrink things, if this point is at 0, which it is here, shrinking it doesn't change the x value. But if this point is at 4, when I shrink things horizontally, I'm cutting those x values in half. If I take half of 4, that's 2. Now I've got 2, 0. This point's going to become 5.5, 1. And this point is going to become 4, 2. Those are the 3 points that Maud got. Okay. So it's perfectly fine to use this version of things. I'm just not crazy about it because it looks like we're shifting to the right 4. We are, but after we do the shift, we have to shrink the amount that we shifted by. With this version, when I factored out the multiplication, that number that I'm adding or subtracting will correspond to ultimately how far I've shifted things. So I prefer to write things in this form rather than multiply and then subtract, factor out whatever I'm multiplying x by so that the addition or subtraction is in parentheses. Not necessary, I just think it's helpful to be able to look at that and see that it should look like I shifted it to the right by 2.